Welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're going to learn some stuff about bubbles and then you're going to do an experiment. Are you ready to get started? Great, let's go. Who here has played with and blown bubbles before? Me too. Maybe you've blown bubbles out of a bottle like this, or played with bubbles in the kitchen sink, or even the bathtub. Today we're going to learn a little bit about how bubbles work and how they stay together. I'm going to pause for a minute and let 3 of you tell your teacher something you already know about bubbles, or when you've played with them. Now, I need one person to tell your teacher what shape you think bubbles are. Have you ever blown through a straw and made bubbles in your water or milk? When you blow air into a liquid, you make bubbles. When the bubble gets too big or bumps into something else, it pops. Have you ever heard the science words molecule or atom? Even if you've heard them, you've probably never seen one because they're so tiny they can only be seen with a special microscope. Everything is made up of atoms. You are made of atoms, your friend is made of atoms, your desk, an apple, a chalkboard, and atoms make up molecules. Let me give you an example. Take the word learn. The word learn is made up of letters. Letters make up words, and words are found in sentences. The letters are like atoms. Atoms make up molecules, and molecules are found in everything. We're going to experiment with water today. Water is a molecule made up of atoms. It has 2 hydrogen atoms and 1 oxygen atom. The molecules in water are attracted to each other. This is called cohesion. When things are cohesive, they stick together. The molecules in water stick together like sticking with or hugging your best friend. The cohesion makes a water molecule strong, and the strength of the water molecule is called surface tension. We're going to do an experiment so we can see surface tension. It's what makes a bubble possible. We see surface tension when we see a drop of water. It creates a little bead, like a dome. First, let me show you cohesion. I'm going to fill a cup of water as high as I can without spilling it. Now you know why I have this tray here. Then I'm going to use a dropper or a pipette to add a few more drops so it's as full as it can possibly be. All right, that might be enough. I'm going to use a fancy science word now, estimate. I'll wait while you and your class estimate how many paper clips you think will fit into the cup before the water overflows. Okay, here we go. Watch as I begin dropping the paper clips in one at a time. I need you to do the counting for me. 2 stuck together, we'll start there. Are you counting? Let's keep going. 2 more. There it goes. Can you see the dome of the shape of the water? Did you see that shape? That's cohesion. The drops of water are sticking to each other. And as we added the paper clips, the top of the water formed a dome and the water molecules stick to each other before they spilled out. Eventually, there were too many paper clips and the surface tension broke. That's when the water spilled over. Let me show you something else. Let me get a piece of wax paper Now look closely at these drops. What do you see? What shape is it taking? Do you see a dome shape? This is cohesion and surface tension. Do you have any idea what would happen if we tried to break or separate the droplet? I'm going to use a toothpick and poke at it. Watch this. Anything happen? Was I able to break the cohesion? Nope. Like we said before, they're just like you and your best friend. They're sticking together. Now let's try this. I'm going to poke the water drop with a toothpick that I'm going to dip in this bubble solution. This is like using dish soap. Ready? What happened? Why do you think this is happening? When I poked it with a soapy toothpick, the water spread out. When there was cohesion, the molecules stuck together. When I added soap to the water, the molecules of the soap spread over and broke the cohesion. Now, I get to use this. As I blow a few bubbles using a round bubble wand, please share with your teacher what shape bubbles you see and what size they are. It's time for you to do an activity with me. Let me show you first, and then your teacher will get you all set up. We're going to need a pipette, a penny, or a coin, or even a bingo chip like this, some water, and somewhere to work. Your desk or your table is fine. Now, watch me do this. I'm going to put my pipette into the water and squeeze the top so it sucks up some of the water. Then hold it over the coin and slowly squeeze the top to drop water onto the coin. Do you see what I'm doing? I'm going to keep adding drops of water. Let's use a very special science word, predict. To predict means to say what you think will happen. So before you begin, predict how many drops of water will fit on the coin without spilling over. Will it be 2? Will it be 10? More than that? Go ahead and test your predictions. I'll wait for you. Great job. Are you ready for another activity? You're going to receive a worksheet from your teacher. I'll wait for everyone to get one and for you to put your name on it. Your job will be to make bubbles using different shaped wands. Before you do that, I want you to make predictions. Remember, predict means to say what you think will happen. You're going to use different shaped wands, like some of the ones I have right here, and predict what shape your bubble will be when you use a different wand. Teachers, have the students fill out just the first column of their worksheet. Make those predictions. What shape do you think the bubble will be when using a different shaped wand? I'll wait while you fill out the first column and while you set up your stations. Okay, I think we're ready. You will see that your teacher has set up 5 stations. At each station, there's a bowl or a plate with bubble liquid in it, maybe something like this. And there are a couple of bubble wands, maybe a shape like this, or even this one. When it's your turn, you'll go to one station and use that wand. When you blow your bubble, notice the shape of the bubble and notice the size. Is it small, medium, or large? Make sure you follow the directions of your teacher. You'll be told what station to go to. When you're done, go back to your seat and fill out the last 2 columns of the station you went to. Okay, teachers, I'm turning this over to you right now. I'll see you back here when you're finished. Welcome back. I hope you enjoyed that. Let's review a few things that we learned today. Thumbs up if you remember learning about a water molecule. Yep, that's good. We talked about hydrogen atoms and an oxygen atom that are stuck together like friends. Thumbs up if you remember that that's called cohesion. Thumbs up if you remember that a water bead has that dome shape, and that's called surface tension. Great job! Last one. Thumbs up if you agree that no matter what shape wand we used, the bubbles were all round. Excellent. You all did a great job today. Thanks for joining me. Teachers, thanks so much for using this WOW lesson, and please check out more at our website at wpafbstem.com.